we look at comparing individuals from different demographic groups, it's important to consider how they relate to their particular group. And we want to look at not only how an individual relates to the average of their group, but also how spread out the group is. For example, if the group is very, very consistent and very close to the average, and an individual is a couple points away, that's a much bigger difference than if the group is very spread out and not consistent and the individual falls somewhere in that spread. So in order to make comparisons about individuals from different demographic groups, we look at what is called a z-score. A z-score allows you to account for the individual's value as it relates to the mean. So we take the individual's value and subtract the mean to get a handle on how far away they are from the mean. Lastly, we divide by the standard deviation to get a handle on how the standard deviation comes into play. This essentially scales the value and tells us how many standard deviations away an individual is from the mean. So I've collected information on my 3 different kinds of dogs. There they are, Banjo, Seneca, and Abby. And what I want to take a look at is how do they relate to their specific demographic groups? How much heavier or lighter are they than the dog on average of their breed and gender? And how does that relate to standard deviation? So let's take a look at the data and calculate the z-scores for each individual dog. The higher the z-score, the farther away the individual is from the mean, or the group standard. The lower the z-score, the closer they are. Z-scores can also be positive or indicate the individual is higher than the mean, or negative, indicating that they are less. So let's take a look at my individual dogs. What we have here is my 3 dogs, Banjo, Abby, and Seneca, along with the average for their particular breed and gender, and the standard deviation. Now we're going to go ahead and calculate the z-score for each individual animal, and then we'll compare the 3 at the end. Starting with Banjo. In the z-score formula, the x value is the individual's data. The individual in this case is Banjo. He weighs 97 pounds, while the average is 85, and the standard deviation is 8. Looking at the 97 minus 85 tells us that he is 12 pounds heavier than average. Lastly, we divide by 8, or the standard deviation, to see that on Banjo, he is 1.5 standard deviations from the mean. Next, let's take a look at Abby. Abby is 62 pounds, while the average is 71 pounds. So Abby is below average. She is 62 pounds minus the average of 71 divided by the standard deviation of 6. Abby is 9 pounds below average. And note, we do preserve that negative sign. It is important in this case to indicating below average. And we'll divide by the standard deviation. And coincidentally, her value is also 1.5, but it is below average or negative. Lastly, we'll look at Seneca. Seneca is 35 pounds minus the average of 33 over the standard deviation. That provides us with 2 pounds above average divided by the standard deviation of 2.4, and we get a z-score of 0.8333. Typically, z-scores are rounded to 2 decimal points, so we'll leave that as 0.833. What we notice is Seneca is closest to typical for her group. Her z-score is the lowest at 0.83. While Banjo and Abby actually have the same distance from the mean, they're 1.5 standard deviations. The only difference is Abby is below and Banjo is above, but they are both farther away from what is typical of their particular group than Seneca is. So z-scores, once calculated, allow us to compare different individuals that come from different demographics and make a more fair comparison, accounting for both the mean and the standard deviation.